Now we will find out at what particular position on the final screen from the origin, right? So this was the setup. Here I have. So on the final screen, let this be O. So this is my theta. Suppose I'm getting the first dark here. Okay. So I want to find out at what angle I can get the first dark. Likewise, I want to find out at what angle I can get the second dark, or I can also find out at what angle I'm getting the first bright and the second bright. Likewise, I want to find out the angles. Why we are doing that? If we can find out the angles and the path difference, that equation will help us to find out the wavelength, and so many other applications are there. Okay, so now we are finding the angular positions of dark and bright fringes. We can call them as dark and bright, or constructive or destructive, likewise. Okay, we want to know the position, the angular position of the first bright fringe. Okay, so the first bright will have some path difference. To have the first bright, what should be the path difference? D sine theta is equals to lambda. Okay, at this particular path difference, we can have the first bright fringe. Okay, so if I send this D to that side, it will go downstairs, and I'll be remaining with sine theta is equals to n lambda. When we do this experiment, we put the final screen so far away from the slit. If the slit and the screen is having a large distance between them, then the angle which this ray is making, the first bright is making, will be so much smaller. So when the angle is smaller, you see, if this is the final screen, and if I have to look at the first bright, I have to look something like this. This is the position of the first bright. But if I do the same experiment, but if I place the screen away from me, so I don't have to look much up. Okay, but if I put the screen so near to the slit, if I want to see the first bright, I have to look something like this. I have to move upward with greater angle. So that's why here in this experiment, the slit and the screen having bigger distance between them, so that's why the theta is going to be small. And we know that when the theta is small, so the theta can be replaced, sine theta, the sine theta can be approximate to theta. So theta is equals to lambda by d. So this is the angular position for the first bright fringe. So because it is for the first, I'll write it as theta 1. Similarly, if you want to do for the second bright, what is the path difference for the second bright fringe? It will be d sine theta, d equal to 2 lambda. Okay, because it's 2 lambda now, the theta 2 can be written as 2 lambda by d. This is the angular position of the second bright. So similarly, if I generalize it, theta n lambda by d. With the help of this equation, you can find out the angular position of any fringe you want. You just give the number. If you want to find out the angular position of the first, give this give n equal to 1. If you want to find out the angular separation for the fifth fringe, give n equal to 5. They'll get the angular separation, this angle for the fifth fringe. So similarly, we can do for the destructive, we can do for the dark fringes also. If you want to get the angular position for the dark fringes, what you have to do, instead of taking lambda, we have to take lambda by 2. Now we are finding the angular position of dark fringes. So the path difference for the dark fringe is equal to, if you want to find out the first dark fringe angular position, it is lambda by 2. Okay, it is the first dark fringe. Okay, so similarly, theta can be sine theta can be replaced with theta. That's how we can get the first dark, the angular position of the first dark will be like that, and you can find out 3 by 2 t. This is the angular position for the second dark, and if we generalize it to the nth dark fringe angular position, it can be written as n plus half lambda by d. So with the help of this equation, you can find out the angular position of any dark fringe you want. So now I want to find out the linear distance. You see what I mean by that is, so now I will find out at what particular distance I can have the first bright or the second bright or third bright from point O. So these are my slits. Okay, and this is the final screen. The distance between slit and the final screen, I'm calling it as L. Okay, so this is my point O. Somewhere, suppose here, I'm getting a dark, first dark at position x1. So the angle will be, suppose the angle is theta. We know the path difference is what? From this figure, we know that tan theta x by L. Okay. Now, suppose this is the position of the first nth bright fringe. So the path difference for the nth bright fringe is n lambda. The sine theta can be written as n lambda by d, and we know that for small angle approximation, the sine theta can be written as tan theta. As I told you earlier that the angle is very small, that's why I can replace sin theta with tan theta. Okay, so this can be written as tan theta is equals to n lambda by d, and tan theta can be written as x by L is equals to n lambda by d, and that's how this x can be written as n lambda by d into L. So this is the position, the distance of nth bright fringe. If you want to find out the distance of first bright, put n equal to, here this is for the nth bright fringe. If you want to find out the distance for the first bright, put n equal to 1, here it will be lambda L by d. If you want to find out the distance for the second bright, put n equal to 2. Likewise you can find out. Similarly, this was for the bright, and we can do for dark also. So dark fringe, the path difference will change. Path difference will be d sin theta will be equal to n plus half lambda, and sin theta can be written as n plus half lambda by d, and this can be written as tan theta, and tan theta can be written as x by L n plus half lambda by d, and x sub n can be written as n plus half lambda L by d. So this is the position from point O to get. This is the position from point O. With this we can find out the position of the distance of dark fringes. If you want to get the distance of the second dark, put n equal to 2. Distance of the third dark from O, put n equal to 3. Distance of the fourth dark from O, put n equal to 4. Okay, so that's it for today.